Hello friends, so in this class we are going to continue our discussion on trigonometric functions. So in the last class we saw the concept of angles and how do we measure angles in radians and degrees and how are radians and degrees related. So in this lecture we are going to start about trigonometric functions, namely sine x, cosine x, tan theta, sec theta, cosec theta and cot theta. These are the main six trigonometric functions. So, in fact, only sin x and cos x, sine and cosine, these two are the core functions of trigonometry, and rest all four can be derived from this sin x and cosine x. So, we will start our discussion. So, first, let me draw a circle to explain this all the concepts. So, so this is our circle, and so let this be our circle and its center be at the origin. So its center at 0 0 and its radius is r. So this is a point P and this value is r. It's the radius of the circle. And this length is a, this length is b. So the coordinates of this point P will be, so from origin it's a on the horizontal axis, so a, and b on the vertical axis. So its coordinates are a and b. And let this angle be theta. So let's take some more points. This is point A, this is B, this is C, and this point is D. So this is at an angle of 0 degree or 0 radians, both are same, 0 radians. This is at pi by 2 radians. This is at pi radians from this side, from the side OA, from this axis. These are the reference angles, 0, pi by 2, pi, and this is 3 pi by 2. And let me write down their coordinates also. So its coordinates are, this complete length is r, so r and 0. Its coordinate will be 0 and r. So here r is the radius of the circle and clearly it's a positive number. greater than 0, and its coordinate would be minus r 0, and here 0 minus r. And this point is Q. So our two main trigonometric functions are sine and cosine, and rest others are derived from it. So we will define what are sine and cosine functions. So this angle is theta, and sine of theta is defined as, and this is the perpendicular from P to this radius. So this forms PO and Q forms a right angle triangle, right angle at Q. So in this triangle, theta is one of the angles. So sine of that angle theta is defined as perpendicular upon hypotenuse. So perpendicular here is B and hypotenuse is R. And cosine of theta is defined as base divided by hypotenuse. So here base is A divided by R. So this is the definition of sine and cosine. So if we take any point P on a circle AB with radius R, then we can define sine and cosine in terms of the coordinates of that point and the radius of the circle. So here sine theta and cos theta are defined in terms of A and B, the coordinates of point P, and the radius of the circle. And these angles 0, pi by 2, pi and 3 pi by 2, these are multiples of pi by 2. So all the multiples of pi by 2 we give a special name. We call them quadrantal angles. Why? Because these angles divide this plane into 4 quadrants. So each quadrant is so this divide the plane into 4 quadrants: 1, 2, 3, and 4, and each make 90 degree from the previous one. So these are multiples of pi by 2, and these angles, all the multiples of pi by 2 are called quadrantal angles. So now we will see some properties. So first, what happens if we do sine square theta plus cos square theta? So sine theta is b by r and cos theta is a by r. So square of these will be a square by r square, and b square by r square. So I will take r square common. A square plus b square by r square. And in a right angle triangle, so if we have a right angle triangle, Then perpendicular square plus base square is equal to hypotenuse square. So in this triangle POQ, B and A are base, perpendicular and base respectively, and R is the hypotenuse. So this will be equal to R square divided by R square. So it will be equal to 1. So sine square theta plus cos square theta is equal to 1. So we should remember this formula. We will see more of this kind of formula. Now we define some other trigonometric functions using sine and cosine. So we will define tan theta. We will define sec theta. We will define cosec theta and cot theta. So tan theta is the ratio of sine and cosine. So it's sine theta divided by cos theta. So what will be its value? Sine theta is B upon R, cos theta is A upon R. So R will get cancelled. So we will get B upon A. Sec theta is 1 upon cos theta. So we will get R upon A. Cosec theta is 1 upon sine theta. So we will get R upon B, and cot theta is 1 upon tan theta. So we will get A upon B. So this also we should remember. And now we will see some properties, like in the last lecture we had seen that our main angles. So let's see this figure. So we know that sine of any angle theta will be calculated using the coordinates of any point on the circle and the radius of the circle. So at point A, if we calculate sine and cosine, what we will get? So we have points A, B, C and D. Let me write here. We have point A, point B, and here I will take point C and point D. So at point A we have 0 degree or 0 radians. At B we have pi by 2 radians or 90 degrees. C is pi radians or 180 degrees, and D is 3 pi by 2 radians or 270 degrees. Now I will calculate the values of sine and cosine at these points. So here theta is pi by 2. So I can directly write, oh sorry, theta is 0. So I can directly write 0. Sine of 0 is equal to, so here these are AB pairs. So, so if I take a point A, point P with coordinates AB, generic coordinate AB, then here A is equal to R and B is equal to 0. At B, A is equal to 0, B is equal to R, and so on. So let me write down the coordinates also. R0. So here theta is 0, A is R and B is 0. And for C we had minus R0. B is 0R and D is 0 minus R. So here sine of 0 is B upon R. So here B is 0. So we will get 0 upon R, which is 0. And cos of 0 is A upon R. So here A is R. So R upon R equal to 1. So sine of 0 is 0 and cosine of 0 is 1. Now at point B, theta is pi by 2. So we will write sine pi by 2. So here it's the reverse. A is 0 and B is R. So sine will be B upon R, which is R upon R, is equal to 1. And cos pi by 2 is equal to 0 upon R is equal to 0. So we see that for 0 radians, sine is 0, cosine is 1. For 90 degrees or pi by 2 radians, sine is 1 and cosine is 0. Now for when theta is pi, we get sine pi. Again b is 0, so it will be b upon r, that is 0. And cos pi, so here a is minus r, so we will get minus r upon r, which is equal to minus 1. And for this case, sine 3 pi upon 2, b is minus r, so we will get minus r upon r, which is minus 1. And cos 3 pi by 2, it's equal to 0 upon r or 0. So for all the multiples of pi by 2, so now if I take, so this is 0, this is pi by 2, next multiple of pi by 2 is pi, next is 3 pi by 2, next is 2 pi. So 2 pi is same as 0. So 2 pi is 360 degree, which means 1 revolution. So if I do one complete revolution, we will reach at the same point. So if I start at point P, so this is a circle and this is a point P. which makes an angle theta. Then I do one complete revolution. So this complete revolution is 2 pi. So again we will reach here. So from theta I add 2 pi again. So I reach again at theta. So theta is equivalent to 2 pi plus theta, or any multiple of 2 pi, 2 pi k plus theta, where k belongs to integers. So this is true for our trigonometric functions. So we have seen the values of trigonometric functions at all the multiples of pi by 2. So when is sine of any angle 0? So sine of angle is 0 at 0 degree. So sine theta is equal to 0 when at 0 degree, then at pi degree, and again at 0 plus 2 pi. If we add 2 pi to any of the values, it remains unchanged, 2k pi. So next we add 2 pi to 0, it will become 2 pi. Then we add 2 pi to pi, we get 3 pi. Then 4 pi, 5 pi, and so on. So generic term would be n pi, where n belongs to the set of integers. So sine theta is 0 for theta equal to n pi. Similarly, we see when is cos theta equal to 0. Cos theta is 0 at pi by 2. Three pi by 2. Then 5 pi by 2. Then 7 pi by 2, and so on. So the generic term in the top, it's 1, 3, 5 pi, all the odd multiples of pi. So we can write 2n plus 1 pi in the numerator and 2 in the denominator. So here again n belongs to z. So if n is 0, we get pi by 2. If n is 1, we get 2 into 1 plus 1, that is 3 pi by 2. If n is 2, we get 5 pi by 2, and so on. So this form we should remember, it will be helpful in solving our questions quickly. Otherwise every time we will have to derive these. So sine theta is 0 at n pi, cosine theta is 0 as 2n plus 1 by 2 pi. So from sine theta we will now move to its reciprocal, that is cosec theta. Cosec theta is equal to 1 upon sine theta. So for any function, any rational function which is expressed as a ratio of two functions, fx and gx, fx divided by gx, the denominator should not be equal to 0 for that function to be defined. So here we know, we have seen that sine theta can take value of 0 also at uh, at the values of theta and pi. So here the condition is that for this ratio to hold, one condition is that theta should not be equal to n pi. So all the values of theta where this denominator becomes 0, sine theta becomes 0, it should be excluded. So sine theta is defined for all the values of theta, but cosec theta, which is the inverse, the ratio of 1 divided by sine theta, reciprocal of sine theta, it's not defined for the integral multiple of pi. Similarly, sec theta is equal to 1 upon cos theta, and here the condition is that theta should not be equal to this value, because when theta is equal to 2n plus 1 pi by 2, then cos theta is 0 and 1 by cos theta will not be defined. Similarly, tan is also ratio of sine and cos. So again here all the values of theta for which cos theta is 0, we will exclude those values. So again we will get the same value. Two n plus 1 by 2 pi, and cot theta is cos divided by sine. So here sine theta should not be 0. So theta should not be equal to n pi or any multiple of pi. So these are the conditions. So sine theta and cos theta, these are defined for all the values of theta, and the rest other four which are derived from sine and cosine, these should not, here theta should not be equal to, for some cases n pi and for some cases 2n plus 1 by 2 depending on what's in the denominator. So these are the four conditions for these four trigonometric functions. So now we will see, we have seen that sine square theta plus cos square theta was equal to 1. Similarly, so we had derived it here, sine square theta plus cos square theta is 1. If we put just a by r, b by r for sine and cos, we will get the result. So there are other results which can be proved in similar way, which you should remember. So the another one is sec square theta minus tan square theta. This is also equal to 1. And the third one is cosec square theta minus cot square theta. This is also equal to 1. So it's good to remember these three relations. So we can prove the other two also using just substituting the values a in terms of a, b, and r, and we will get the result. So these three we should remember: sine square theta plus cos square theta is equal to 1, sec square theta minus tan square theta is equal to 1, and cosec square theta minus cot square theta is equal to 1. Now I will write the value of sine, cos, and tan in terms of our major degrees. So the main degrees, the angles in the main angles that we had discussed in the last lecture was 0, then 30 degree, which is pi by 6, 180 divided by 6, 30 degree, then pi by 4, this is 45 degrees, then we have pi upon 3, this is 60 degree, 180 divided by 3, then we have pi by 2, 90 degrees, then 3 pi by 2, and finally 2 pi, 360 degrees. And we will see the values of sine theta. So these are the values of theta, and we will see the values of sine, cos theta, and tan theta. So for 0 we had seen that sine theta is 0, cos theta is 1. So we had seen this, and tan theta is the ratio of sine and cos, so it will be equal to 0. For then we had seen for pi by 2, sine is 1, cos is 0. So tan is 1 by 0, so it's not defined. So I will write infinity here. And for 3 pi by 2, it's minus 1 and 0. Oh, I have missed pi here. So pi 180 degrees. So for 3 pi by 2 again it will not be defined, minus 1 upon 0. For pi, sine is 0, cos is minus 1. So tan will be 0 upon minus 1, that is 0. And for 2 pi again, sine 2 pi is same as this 0 degree. So we can directly copy the values from 0. Now if we see pi by 4 or 90 degree or 45 degrees, so it will be exactly in the middle of this. And this is 90 degree, this is 45 degree, so this is also 45 degree because sum of all angles is 180 degree. So this value and this value, the length of other two sides excluding this r has to be same. So a is equal to b. So sine and cos both are same here. So if this radius is equal to 1 and this a square plus b square is equal to 1, a square plus a and b are same, so we can write a square plus a square is equal to 1, or 2a square is equal to 1, or a square is equal to half, or a equal to plus minus 1 upon root 2. But we will ignore the negative values because it has to be positive. So a is 1 by 2, 1 by root 2. So a is 1 by root 2 and b is also 1 by root 2. So sine theta is equal to a divided by r is 1, so 1 by root 2. So this was for pi by 4. Sine is 1 divided by root 2. Cos is also 1 divided by root 2. And tan is the ratio of sine and cosine, which both are same, so it will be 1. And for 30 degree, sine is equal to half, cos is equal to root 3 upon 2, and tan will be 1 upon root 3 sine upon cos. And for pi by 3 it will be reverse. The value for pi by 6 for sine and cosine, the values will reverse. Root 3 by 2, cosine is 1 by 2, and tan of 60 degrees root 3. So it's good to remember these values as well. In the process of solving the problems, these values will automatically get memorized. So now we will see the sign of trigonometric functions. So we see that these angles 0, pi by 2, pi and 3 pi by 2, this divides the plane into 4 quadrants. So I will draw 4 quadrants here. So this we will call quadrant 1. This is quadrant 2. This is third quadrant and fourth quadrant. First quadrant is from 0 to 90 degree. Or pi by 2. Second quadrant is from pi by 2 to pi. Third quadrant is from pi to 3 pi by 2. So we will see the sign of these. So here, if we draw a circle here, then all the, so suppose there is a circle with center at origin. So any point on this part of the circle will have both x and y as positive. So sine would be positive. A, B and R. R is always positive. A and B both will be positive here. So sine will be positive, cos will be positive, tan will be positive. And their reciprocals, cosine, again the reciprocal of positive number is positive, reciprocal of negative number will be negatives. So their reciprocals will also hold the same sign. So now in this part of the circle, the x coordinate of any point will be negative, but its y coordinate will be positive because it's above this horizontal axis. So x coordinate is only negative. So sine theta is y upon r. So here b is the y coordinate and cos depends on the x coordinate. So in this part x coordinate is negative. So cos will become negative and y coordinate is positive. So sine is positive. Now tan is the ratio of sine and cos. So if any one of numerator or denominator is negative, then it will become negative. Here for this part of the circle, both the x and y coordinates will be negative if we take any point on this part of the circle. So sine will be negative, cos will be negative, but tan is the ratio of negative and negative, so it will become positive. And similarly cot will be positive. And now we are left with this red part of the circle. So in this part x coordinate is positive because it's to the right of this line, but y coordinate is negative because it's below this line. So cos depends on x-axis. So x-axis is positive. So this cos will be positive. Sine depends on y-axis, y coordinate. So it will be negative. Tan is the ratio of negative and positive, so it will be negative, and cot will also be negative. So in first quadrant,